Hundreds of millions of years ago, and over long periods of time, the remains of plants and animals built up in thick layers on the Earth's surface and ocean floors. Over time, these layers were buried under sand, silt, and rock. Pressure and heat then changed some of this carbon and hydrogen rich material into coal. Some of it was converted into oil, and some into natural gas. So here's a coal production facility, and here's a bit of an overview of different types of coal. So let's focus on this. Let's focus on coal, of which there are many forms, as illustrated above. This can include lignite coal, subbituminous coal, bituminous coal. All have different moisture and energy contents, but the process for their combustion is largely the same. Okay, so here is a bit of an overview of the coal combustion process. In a basic overview, coal is transferred from a nearby mine and transported to a coal handling area where it is crushed and conveyed into the pulverizer. The pulverizer further grinds the coal into a dust which is transferred to burners. As heat is emitted from the burners, it generates steam from the boiler. The steam passes through the turbine, which then drives the generator. The generator essentially converts the work produced from the turbine into electricity. A transformer is required at the site of any coal plant to convert the electrical power to a higher voltage where it can be sent through the transmission lines to the grid. Any flue gas from the boiler is discharged through the stack. Inlet and outlet canals are also available to supply cooling water to the condenser under the turbine. So why is coal problematic? Essentially it comes down to flue gas, which is what would be released out here through the stack. Flue gas is essentially any gas exiting to the atmosphere via a flue, which is a pipe or channel for conveying exhaust gases. The flue gas, however, which is emitted from coal, includes things like sulfur, nitrogen, and a very high concentration of carbon dioxide. Coal is naturally about 60% carbon by weight. Once it is combusted, this carbon is then emitted at a higher concentration, arguably than any other major fuel alternative. So there's going to be more on this to follow. Natural gas. So what is natural gas? Natural gas is also a fossil fuel energy source that's formed deep beneath the Earth's surface. Just like coal, natural gas is the result of decayed plant and animal matter that were converted through enormous amounts of heat and pressure over time. Natural gas does contain many different compounds. The largest component of natural gas is methane, but it also contains smaller amounts of natural gas liquids, which are also hydrocarbon gas liquids, and non-hydrocarbon gas liquids, such as carbon dioxide and also water vapor. So where is natural gas found? In some places, natural gas kind of moved naturally over processes into large cracks and spaces between layers of overlying rock. The natural gas found in these types of formations is sometimes called conventional natural gas. It's easy to extract. In other places, however, natural gas occurs in the tiny pores, in these tiny little spaces within formations of shale, sandstone, and other types of sedimentary rock. This natural gas is referred to as shale gas or tight gas. It's also sometimes referred to as unconventional gas. Natural gas deposits are found both on land and some are also found offshore, as well as deep under the ocean floor. And then there's also a type of natural gas that's found in coal deposits. This is called coal bed methane. Regardless of the differences from where natural gas is sourced, the combustion process is largely the same. So here we have a bit of an overview of the natural gas combustion process. So from the wellhead, you can see that here at the top left, natural gas is then sent to processing plants where water vapor and non-hydrogen compounds are then removed, and then the natural gas liquids are separated from the wet gas and sold separately. So natural gas plant liquids, also known as NGPL, are separated from the processed natural gas, which would be referred to as dry consumer grade or pipeline quality natural gas. Some wellhead natural gas is sufficiently dry and it will satisfy immediate kind of pipeline transportation standards without any processing. Chemicals are often called odorants and added to the natural gas so that pipeline leaks in natural gas pipelines can easily be detected. Dry natural gas is then sent through pipelines to underground storage fields or to distribution companies and then to consumers. So now let's talk a little bit about how gas is combusted. This is kind of the process for where gas moves as it is pulled from the wellhead, separated into natural gas liquids, and dry kind of consumer grade natural gas goes through a turbine producing steam, and then the natural gas liquids are often kind of separated and sold off differently. So let's talk now a little bit about different forms of gas generation. Simple cycle and combined cycle. Simple cycle. As the name suggests, simple cycle turbines are the most straightforward means of generating electricity from natural gas. In simple cycle generation, a gas turbine compresses air and mixes it with fuel, which is then heated to a very high temperature. It's this hot air-fuel mixture which moves through a gas turbine blade, making them spin. Heat produced during the combustion process turns a turbine and generates electricity. In combined cycle, a gas turbine will compress air and mix it with a fuel that is heated to a very high temperature, just like simple cycle. That hot air-fuel mixture moves through the gas turbine blades, making them spin and generate electricity. However, there's also in combined cycle generators a heat recovery steam generator. What this does is it captures exhaust heat from the gas turbine, any kind of exhaust that would otherwise just escape through an exhaust stack, and it creates steam from this. And it delivers that kind of to the steam turbine, generating additional electricity. So as a result, in combined cycle generators, they are much more efficient, but also slower and more costly to operate. So let's walk through some of the differences listed on this slide. Simple cycle, there's typically only one turbine. It is favored to meet peak load demand, quickly achieves full generation capacity ramping up, which is part of the reason why it's favored to meet peak load demand. They operate at about a 35% efficiency. In combined cycle turbines, there's two. There's the gas and there's the steam turbine. It is favored to meet base load demand. It does take a lot longer to meet full generation capacity to kind of ramp up the system, but it is more efficient. It operates at about a 55% efficiency. Now let's talk about cogen, also known as combined heat and power. This is the production of both electricity and heat from a single fuel source. Powered by a gas turbine, mostly, but not always, a cogeneration system is a highly efficient way of capturing heat which would otherwise be lost during the production of electricity and then converting it into useful thermal energy. A cogeneration system is both flexible and reliable because it's efficient use of energy. Industrial cogen is more economical and environmentally friendly than conventional fossil fuel power plants. Typically, a gas-powered industrial cogen plant will be located close to an industrial or residential hub to just kind of help ensure quick access to consumers and help kind of reduce any transmission losses from the heat and power that's generated. The installation of industrial cogen offers really big increases in overall plant efficiency. Actually, it's not that uncommon to achieve up to 90% efficiency in cogen plants as opposed to 30 to 40% efficiency with the alternatives. I think you could see some of those efficiency numbers in that previous line. So it's for this reason that cogen is often treated as a more environmentally friendly form of thermal power generation. One of the most interesting facts actually about cogeneration is that it is fuel neutral or fuel agnostic. Basically means that this combined heat and power process can be applied to fossil fuels like coal and gas as well as renewable sources of energy. Now, the specific technologies employed and the efficiencies between them will vary, but in every situation, combined heat and power offers the capability to make more efficient and effective use of any kind of primary energy source.